Hey everybody, this is Larry. This is day 13 for the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today we have 2593's find score of an array after marking all elements. Okay, so you have an array nums of all positive numbers. Let's just jump into it. Also, actually before I start, I didn't do that much today in terms of work or anything, but I just want to actually just kind of give a very quick short story about advent of code. Been kind of terrible this year. I kind of blame it a little bit on ChatGPT, but you don't have to guess that. If you've been doing Leetcode or if you've been doing Leetcode contests, you probably already know the story, or you could guess the story. But I just want to tell a story about never giving up, because you could watch my video from yesterday for advent of code. It's on this channel. But honestly, on part one of the day, I messed up. I misread the problem, so I was kind of just going slowly. So even though this took 9 minutes, probably only 4 minutes of it was on the quote unquote the real problem. So I still have 2 problems for part 1, and on part 2, I already kind of mentally gave up. Not necessarily on the problem, because I wasn't gonna give up on the problem because I was recording it, but also just wasn't gonna give up. But I wasn't going hustling fast. But I was just solving it. But it turns out you never know. It was a hard enough problem, and in part 2, was able to finish in the top 100 for 46 points, top 55th. So pretty good advent of code day. Very interesting. Still not gonna finish in the leaderboard, I don't think, honestly, on the global leaderboard in the final. But it is what it is when you play against bots and computers, right? So it's not a huge deal, but it is what it is, right? So okay, so having if I were to kind of tell a story about it, it is just that, hey, keep working, keep grinding, keep solving problems. You never know. Sometimes you just get a little bit lucky, right? And that's all you can ask for sometimes. Anyway, preparation, and sometimes you even beat the bots. All right, find scores of array marking all elements. Okay, choose the smallest integer of an array that's not marked. If there's a tie, choose one of the smallest index. Add the value of the chosen integer to the score. Mark the chosen element and its 2 adjacent elements if they exist. Mark the chosen and its 2 adjacent elements if they exist. Repeat until all the array elements are marked. Okay, I think this is kind of similar to what we were talking about yesterday, right? With the heap, if you're gonna repeatedly take the smallest element, then maybe it's a heap problem. For this one, actually, not quite that, only because each element can only be picked once. Where yesterday's problem, you could pick an element and then later pick the same element, right? So because of that, you actually don't need a heap. You could just do a sort. And that's what I'm gonna do. That's basically what I'm gonna do, I think, right? So maybe you can think about different ways of writing it, but maybe I will have rank is equal to I for I in range of n, right? And rank just means the index of where it is, right? So then now we can sort rank by we have a lambda of I, right? And then we just sort it by nums of I. So then this now rank is sorted by, so now let's just print it out for a little bit of visualization real quick, right? Okay. Oh, silly. Whoops. And what that means is that the smallest element is going to be on 0, which is index 1, right? And then the second element is going to be 1 and 2 and so forth. And maybe just to this should be a stable sort, and stable meaning that earlier in the order is earlier in the result if they have the same value. In this case, for example, the 2 2s on part the example input 1. But if you really want, you can of course add the index to itself as well. If you just want to be really sure and you don't remember whether Python has a stable sort, remember not every language default sort is stable. I believe C++, and maybe I'm wrong on this one, but this is in the back of my mind because I haven't used C++ that much lately, right? But my understanding or my memory is that C++ have both a sort and a stable sort. So you have to use the right one if you're going to kind of think about using this kind of idea. But okay, anyway, from that, all we have to do now is just, have maybe even use the terminology that they have, which is marked is equal to force times n. And then now we can say for I in rank, we can say if marked of I, or if not marked of I, then we add this number to score, right? So score is equal to 0, then score we add num sub I, right? I is a little bit confusing, so I'm going to rewrite this because it's I in rank. So actually, maybe this is R for each number in rank. So this is the index that is in nums, not the not an I, like I from 0 to n or something like this, right? So that's basically the idea. But then after that, of course, you want to do is equal to true. You want to do mark r minus 1 is equal to true, and marked r plus 1 is equal to true, right? And that's pretty much it. Of course, anytime you have something like that, you have to think about the bounds, right? So we just have to make sure the bounds. So if r minus 1 is greater than equal to 0, we have this. And then if r plus 1 is greater than, oh, whoops, a little bit too fast. Do this, and that should be good. So yeah, let's give it a spin. Looks okay. So let's give it a quick submit. And there we go. Pretty fast. Just a really quick sorting idea. We use a couple of O of n things like rank and score. And that's pretty much it. And in theory, you actually don't need an extra rank. You could maybe even sort nums itself, but I consider it the same extra using space anyway. So I don't know. So that's the same idea, but I just want to write it out differently a little bit today, just to kind of give you an idea of what you can do without manipulating the input, right? And yeah, O of n extra space. We have one here and here, right? And n log n because we have a sort. And that's pretty much it. That's all I have for today. Everything else, after you realize that you can sort, is just doing what they tell you. Oh yeah, and you could even, for bonus points, change this into a for loop if you like. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.